Thanks, Fiona. So, yeah, it seems to me that it's been worrying me anyway that perhaps we're not getting the best out of our agents, and sometimes we're trying to overuse agents that really have reached their limits and we're expecting more. And I think there's a very good example we've got. It's an old example, but on it right here that shows what I'm trying to clear up. And it goes back to jointed cactus. Now, the very first workshop that was ever held was to discuss what do we do about jointed cactus. So it hasn't been mentioned for years, so it's good to get it back in the program. But here's a photo of jointed cactus in Natal, in a region where cochineal had never got to. This photo was taken in about the 1970s or 80s. When cochineal got into this area, the vista changed completely. But without the cochineal, we had a blanket of jointed cactus in the veld. And that's what the Eastern Cape looked like before jointed cactus was released in 1935. So if I can just portray it as graphically, with abundance on that axis and time on this axis without worrying about the numbers, we had jointed cactus extremely abundant in the country and increasing in the early parts of the last century. And then in 1935, cochineal was released and really loved the conditions. When the plant is dense like that, cochineal does extremely well. And it moved in and became prolific, and there was an absolute crash of the population of jointed cactus, with great hurrahs, and everybody was delighted, and the problem had gone away, and there was everything was good. And so that was what happened very quickly. But then, ensuing period, the jointed cactus bounced back. And this is a very common phenomenon, where you get an overshoot because something's happened very dramatically, and then things started increasing again. And people at this stage panicked, and they said, this cochineal has lost its toxicity. It was based on nothing, they'd seen the plant rebounding. They said, the cochineal's useless, we need to do something about the problem, otherwise we're going to be back to where we started. And that gave rise to an infamous herbicide control program which went on for many decades. And the taxpayer sponsored it, so that herbicide was provided free of charge to landowners, but they were obliged to apply it, and they deployed gangs of laborers in their veld, spraying every plant they could find. And that went on for years. It cost them millions of rands. And during that period, the cactus didn't really get any worse, but it really didn't get any better. So it just sort of stagnated. And nobody worried about it, they just kept on doing the same old thing, throw the herbicides around and get on with the job. Until Helmut Zimmermann said, let's have a look at really what's going on. And he asked the question, were people right when they said this the cochineal has lost its toxicity? And Helmut did some neat experiments, one of which was to exclude cochineal from plants by spraying them with an insecticide, and then you can compare what happened to those plants to other plants where he allowed cochineal access to the plants. Right? And he monitored three things. First, he looked at plant survival, and over a 5-year period, there was a very dramatic difference. The cochineal plants, 75% had died, whereas 100% survival of the ones without cochineal. He then looked at how many cladodes those plants produce, and again, there's a 6 or so fold difference in the numbers of cladodes they produce, so the growth of the plants was much more prolific without cochineal. And he looked at the numbers of new plants, the reproductive capacity of the plants, and that again was 10-fold difference. So quite clearly, the assumption that cochineal had lost its toxicity was completely flawed, and the insects were still very debilitating for the plant. The other thing that Helmut then looked at was just what was happening to the populations of the cactus in the veld. And he looked at a situation where there was no spraying going on, so he just had his insects in the system. And what he found was that there's a natural cycle going on. Plant builds up in numbers, gets knocked down again, it builds up in numbers and gets knocked down again over time. And if you put into that graph the cochineal abundance on those plants, just measured as a percentage of plants with cochineal, he found there was an out-of-phase cycle with cochineal building up in abundance and then declining. And this is a classical predator-prey response, where the one is keeping the other one in control. So we had this massive herbicide program that clearly showed that cochineal was doing a fantastic job in keeping the cactus in control. We had this herbicide program, which cost millions of rands, which wasn't needed at all, until somebody did the right work and showed, yes, we've we've got biocontrol going, they stopped the herbicides. They said to farmers, you can spray if you want, but we're not subsidizing it. And people reverted to using biocontrol, and nothing has changed really. So what was needed was some decent work to show what the insects were doing, to just get the situation as it should be, rather than what people thought it should be. So I think now we've got lots of other projects going on, 75 agents on 48 weeds. Some of those we consider complete successes, and I think a classic example is the work on Azolla, where that plant has disappeared from the system. Those are easy to deal with. Nobody worries about those anymore, we just get on with them. And at the other end of the scale, we've got projects that we consider to be negligible. So the agents haven't done very much, and I think some classic examples of those are Lantana, Ducosperma, and Prosopis, where we've got the agents in the system, but they're not really doing an enormous amount, and we're not trying to get more out of them. But most of our projects fall into what we call, between those two extremes, substantial successes. So we're getting a lot of value for money, but we're not getting as much as we could do with. And it's really those projects that I think we need to be looking at more carefully and asking the right questions when we want to use those agents. And classic examples of substantial projects are Hackia, many of the acacias. There's a lot of damage caused by the agents, but the weeds are still prominent in the system. And what I want to just try and say the idea today is that when we're looking at those agents, can we ask all sorts of questions before we start planning how we're going to use them in our systems? And these are just some examples of questions that I think are pertinent if we're going to do this. Is the problem affecting land use? Thank you. Often it's, these weeds aren't really problematic. They're there and they're abundant, so they're apparent, but actually they're not really problematic. Can we just live with them as they are? Jointed cactus is probably a very good example. Is the problem getting worse? Is it stable? Have thresholds been properly determined? Do we know what we really can deal with and what we can't? Can resources be better deployed? Should we be working on that agent rather than another one? I don't know if people consider that, but I think it's under considered. What is the possibility of achieving objectives? Are the dynamics of the system properly understood? And you can think of other questions, but what I really want to get the message across is that we need to consider all these things before we start getting implementation programs in place, before we start trying to deploy our agents more than we need to. And really that's all I wanted to say. Thank you very much indeed.